In this problem, we need to find out what reagents we want to use to make the following aldehyde. Is heptanal from the alkane here, which is pentane. Okay, how do we do that? The first thing that we need to notice is how many carbons do we have. So here I have 7 carbons, and here I have 5. So obviously I need to add 2. One strategy that we have done before is use acetylene to add carbons to the chain. We have used alkynes, and so I know that acetylene will have 2 carbons. So let's find out how we can do this. So the first step in that, I'm going to do some analysis backwards. So how can I make, if I had an aldehyde, how can I make an alkyne, for example, an aldehyde from an alkyne? So I can have an alkyne with 7 carbons, so let's draw that. That's 2 carbons, 1, 2, 3, 4, 5, 6, and 7. But if I want to make that, I remember that I have hydration reactions of alkynes, and those will produce either aldehydes or ketones. So the Markovnikov hydration of an alkyne will give you ketones, and the anti-Markovnikov will give you an aldehyde. Let's number the carbons here. 1, 2, 3, 4, 5, 6, and 7. So going from here to here, thinking backwards then, I need to do a hydration reaction. And that hydration will be followed by a tautomerization. So what reagents do I need to use? If you think of the enol of this, let's just write it small over here. So the enol will have 1, 2, 3, 4, 5, 6, that. How do I make that? From here, I can do an anti-Markovnikov hydration, so with 9BBN, followed by hydrogen peroxide and basic base. So I can do that, and I know that enol is never isolated. You get the aldehyde. So I have that point, but I need to keep going backwards. So I need to add those 2 carbons to that chain. So how do I do that? I could make from here an alkyl halide and then attack on acetaldehyde. Let's see if we do that. If I had this alkyne, and if I add here sodium amide, I know that I will make the following anion. And I could make this react with something that has, this is 4 carbon, 5 carbons in an SN2 type of reaction. So 1, 2, 3, 4, and 5. So if I have that, I can make my SN2 reaction. So over here, and get what I want. And so I'll be adding the 2 carbons at the end of the chain. So I get there. But now how I have acetylene, and I know that I can use that reagent in this step, but I need to make the alkyl halide from this. So how do I go from here to here? So let's see what the changes were. I have added bromine and an H. Notice that the way it was added, if you think of adding an H here and a bromine, that is an anti-Markovnikov. That is a hydrohalogenation in which the hydrogen has been added to the more substituted carbon in the alkane. Therefore, what reagent do we need to use to accomplish that? So I'm going to add HBr, but I need to use peroxide to ensure that I have the right reduced selectivity of that reaction. So again, from the alkene, doing an anti-Markovnikov hydrohalogenation, I get the following alkane, alkyl halide, and it's got the 5 carbons I need, that plus these 2. So, and that will come from acetylene, acid-base reaction. I had my nucleophile. So here, SN2 attack, my nucleophilic attack. And I make the alkyne I need. And that will be heptine, right? 1 heptine. And then I will do here a hydration. And the hydration, we know it with the 9-BBN is anti-Markovnikov. And so that's a intermediate, but you never get that. You isolate really the aldehyde. So with that scheme, we have to determine what is the sequence of reagents that I need to use to accomplish the synthesis. So first, I need to use HBr with peroxide. In a second step, I need to add, say, acetylene, but I need to have sodium amide because I'm making that. And in the third step, I did the hydration, so 9-BBN, and followed by the oxidation with hydrogen peroxide. So that is the sequence that I need to be doing. But again, you need to do the analysis, retrosynthetic analysis. I have 7 carbons. That's an aldehyde, can come from the hydration of an alkyne, anti-Markovnikov, and then I need to put the pieces together. I had 7, I have 5 here, and how do I put 2 more carbons? And those came from acetylene.